Welcome to Basic Electrical Engineering lecture series. This is a series of lecture videos for the first year engineering and electrical diploma students. In these videos, fundamentals of DC and AC circuits, network theorems, fundamentals of transformers, DC and AC machines, and renewable energy sources are the topics covered. Sufficient number of numericals are worked out in each session to make the concepts clear to the viewers. For a basic idea about the topics mentioned, please watch these videos from the very beginning itself. If you find the videos useful, please subscribe for the channel, like the video and press the bell icon for notification. Please try to wear a headphone and watch the video for better sound clarity. Thank you all. And now let's start with today's session. So this is session 11. In this session, I'll be covering phasor diagrams, single phase and three phase AC circuits. Some solved examples in these topics. Now first I'll complete star connected unbalanced load, which I left out in the previous session. Directly go to the problem. That is here, the question is, a 400 volt three-phase CBA sequence supply is given to a star-connected unbalanced load with impedances ZA is equal to 6 angle 0, ZB 6 angle 30, ZC 5 angle 45, and the line currents IA, IB, IC. So first I'll mark the line currents. IA, IB, IC. These are the quantities we have to find out. And the supply details are, it's a 400 volt three-phase CBA sequence. It's not ABC. ABC is the positive sequence. This is the negative sequence. CBA means, or instead of that, we can write ACB. CBA, CBA, rotois. From that, I can get the sequence ACB. ABC is like this. ACB is opposite to that. Now, let's take the phase voltages. VA. Normal case, if I take VA here, these phases you can take in any random direction. I've taken VA here. So positive sequence means this should be VB. So now this is negative sequence, it is VC. So this will be VB, ACB sequence. So now, so VB, this phase value, this is at an angle of 30 degree, this is 90 degree, and the angular difference between the phase is 120 degree. Now I'll have to find we have to write down the equation for the line voltages. VBC. VBC means extend VC in the opposite direction. Find the resultant. This is VBC. It is at an angle of 0. VL angle 0. Then VAB, it will come here. VB extend in the negative direction. Find the resultant. This is VAB. So this is VBC. This is VAB. Then VCA will come here. So we can write down. This is VBC. It is 400 angle 0. VAB 400 angle 240. This is 120. So the positive angle is 240. This is VCA. That means 400 angle 120. These are the line voltages. So I took VA, VC, VB, then found out the line voltages AB, BC, and CA. So VAB is, this is 120, 400 angle 120. VBC is 400 angle 0. And CA is, VAB is 400 angle, this is not 120, this is 240. So VBC is 400 angle 0, AB is 400 angle 240, CA is 400 angle 120. These are the line voltages. Now, I marked a point O here at the star points. Now we can write by applying Kirchhoff's current law to this node, we can write this equation IA plus IB plus IC is equal to 0. Because sum of the currents meeting a point is 0 according to Kirchhoff's law. So IA plus IB plus IC is 0. Now I'll mark the voltages. I'll mark this voltage as VA and this voltage VBO and this voltage VCO. So VAO is the potential difference between point A and neutral point O with A taken as positive. This is the polarity of the voltage. Likewise, VBO and VCO. VCO potential difference between B and O with B taken positive. Now, consider the loop VAOB. VAOB. Once more I'll tell you. VAOB, this closed loop. In this loop, VBO plus VAB, this is VAB. VBO, that is this voltage, plus VAB is equal to VAO. That means I am starting from point O and reaching point A, tracing through two different paths. Starting from point O, I am reaching A, tracing two different paths. Add the voltage, then these voltages will be the same. That is VAO, the voltage between A and O with A taken positive. Same voltage we can obtain by starting from O and reaching point A, tracing another path, that is VBO, that is this voltage, plus VAB. See the arrowhead. VBO, that is towards this, to that add VAB, will get the same value VAO. That is this equation. Then BOCB, BOCB, this closed loop, BOCB. This case also, starting from O and reaching point B through two different paths. That is O to B. This is VBO. That is equal to VCO plus V, this BC. This is VBC. That is VCO plus VBC is equal to VBO. This equation. Now, VAO is equal, rewriting the equation, VAO is equal to BO plus AB. Likewise, VCO is equal to VBO minus BC from third equation. So from 2, from 3. Now we can write the equation from current law. IA plus IB plus IC. What are IA, IB and IC? IA is equal to VAO by ZA. That is the potential difference between A and O divided by ZA will give IA. So VBO by ZB will give IB. And VCO by ZC will give IC. So instead of IA, we can write VAO by ZA plus IB is VBO by ZB, IC is VCO by ZC. Now, using these equations, instead of VAO, put it as BO plus AB. Second equation, this part, keep it as it is. And instead of VCO, VBO minus BC equal to 0. Now simplify, we can simplify this. VBO take it out into 1 by ZA plus 1 by ZB plus 1 by ZC is equal to VBC by ZC. Take it to the right side, it will become positive. VBC by ZC minus VAB by ZA. Now substitute the values. VBO into ZA is 6 angle 0. ZB is 6 angle 30. ZC is 5 angle 45. Is equal to VBC is 400 angle 0. VBC is 400 angle 0 minus VAB is 400 angle 240. VAB is 400 angle 240 divided by, here is ZC 5 angle 45, ZC 6 angle 0. So solve for VBO, you can get it as 178 angle 271.15. 27.15. Magnitude 178 volts at an angle of 27.15. That is VBO. So IB is VBO by ZB. So VBO value we got divided by ZB, you will get IB. That is 29.68 angle minus 2.8. IA is written here. IA is this one. VBO plus VAB by ZA. VBO value we got, AB from the Phasor diagram, it is 400 angle 240 divided by ZA, you will get 44.74 angle 98.7. Similarly, IC is VBO minus VBC divided by ZC. VBO minus VBC by ZC. VBO we solved. VBC is 400 angle 0 divided by 5 angle 45. It is 50.98 angle 116 degrees. Now next, Phasor diagrams. Now what is given here is an AC circuit. We have given supply voltage is given, that is 100 volts. Three resistors connected in series, 50 ohm, 30 ohm, 20 ohm. We know that sum of the resistance is 50 plus 30 plus 20, 100. Supply voltage is 100, so for current is equal to 1 ampere. So this 1 ampere will produce voltages across R1. R1 is 50 ohm, so this will be 50 volt. Voltage across this, I'll mark it as V1. This is V2. V2 is 1 ampere into R2 is 30. Therefore, it is 30 volt. Then R3 is 20 ohm. So this voltage is 20 volts. V3 20 volt. Now the Phasor diagram, I'll take the current. Current is 1 ampere as the reference. I is equal to 1 ampere. Then V1, V2, V3, all these voltages will be in phase with I only in this case. So V1 from here 50 volt, this is V1 equal to 50 volt. V2 is 30 volt, that also in phase with I only. This is V2, that is 30 volt. Then V3 is 20 volt. So V1 plus V2 plus V3, that is the total voltage V, which is equal to 100 volts. So V is equal to 100 volt, I is equal to 1 ampere, and all the voltage drops are in phase with V, and total voltage also in phase with I. So all the voltage drops are in phase with the circuit current. So this is a resistive circuit. So in a resistive, so phasor diagrams, what we have to remember is in a resistive circuit, current and voltage, that is current through the resistor and voltage across the resistor, are in phase. So if the current is passing through a pure inductor, then the relation between V and I means this is VR, IR, this is VL, IL. That means voltage across the inductor and current through the inductor. The relationship is current will be lagging the voltage by an angle of 90 degrees. Again, in a circuit across a capacitor, let VC is the voltage across the capacitor, IC is the current through the capacitor. Then the relationship is current will be leading the voltage by 90 degrees. These are the basics of all phasor diagrams. That is, in a resistive circuit, voltage and current VR and IR are in phase. VR, IR. If the voltage across an inductor and current through the inductor, the phasor relationship is current will be lagging the voltage by an angle of 90 degrees. Again, across a capacitor, the voltage across the capacitor and current through the capacitor, the relationship is current will be leading the voltage by an angle of 90 degrees. These are the basic relationships. Now let's take this is a purely resistive circuit. The voltage is in phase with the total voltage as well as the component voltages all are in phase with the current I. Now this is another circuit. It's a resistor and a coil. So there are two resistances here. One is an external resistance, one is the inherent resistance of the choke coil. It is a coil, so coil will be having resistance that is represented as small r. Whereas this R is an external resistor. L is the inductance of the coil. So applied voltage is 100 volts. So reactance values are given. R is equal to 50 ohms. Small r is equal to 20 ohm. This is 50 ohm. This is 20 ohm. Inductive reactance is 71.41. So total impedance of the circuit, square root of R square plus XL square. R, here there are two resistance. So there are one is an external resistor, one is the inherent resistance of the choke coil. So total resistance is 70 ohm. So when we are finding out the circuit impedance, we have to consider the total resistance, that is square root of RT square plus XL square. RT means total resistance. Total resistance is 50 plus 20, 70. So square root of 70 square plus 71.41 square. This is XL. It's equal to 100 ohm. 100 ohm is the total impedance of the circuit. Therefore, current through the circuit is 100 volt divided by 100 ohm, that is 1 ampere. So here Let us take current as the reference. I is equal to 1 ampere. And next we'll consider the voltage across the external resistor, that is VR. So we know the relation in a resistor, current through the resistor and voltage across the resistor, both will be in phase. So we have already taken current as the reference. So we can mark VR in the same direction. That means this is I, this is VR, both will be in phase. Or we have to mark VR in the same direction of I. Next, there is a voltage drop across this small resistance R also. Its value is 20 ohm. The voltage drop will be 20 volt. I'll take it as V small r. V small r is 20 volt. This VR is 50 volts. So 50 ohm into 1 ampere is VR is 50 volt. This is V small r, that is 20 volts. So this is the phasor V small r. From here till here, it's equal to 20 volts. So that also will be in phase with I. I have marked it, we can mark it here also, but to add, I mark it here so that I can find out the total voltage V. So the resistive drops are one across this external resistor, one across the inherent resistance of the chalk coil. So total it will be 50 volt plus 20 volt, 70 volt. That is from here till here, the voltage is 70 volts. Then this is VL, I'll take it as VL. The inductive reactance is 71.41. So current is 1 ampere. So for VL is 71.41 volts. So we know that in an inductor, current lags the voltage by 90 degree, or voltage across the inductor should lead current by 90 degree. So this is the phasor VL. It will be leading the current. I is in this direction. This is leading the current by 90 degree. So the total voltage is VR plus small vr the whole square plus VL square. That will give V square. We can write this relation. V square is equal to VR plus VR the whole square plus VL square. From this you can find out V, because it's a right angle triangle. So VR plus VR, that is OA. VL is AB. So OB square is equal to OA square plus AB square. So V square is equal to VR plus VR the whole square plus VL square. So this is the, so first we are taking current as the reference, then both the voltage drop, voltage across the external resistance, that is VR, which is 50 volt in the same direction of I. To that we are adding a small VR, that's also in the direction of I only, because both are resistive drops. Then voltage across the inductor, it is leading the current by 90 degree. It's marked here. So this is the resultant phasor. So this is V, this is I. So net current is lagging the voltage. So V is leading the current, or I is lagging the voltage, lagging behind the voltage. So the circuit is inductive. Current is lagging the voltage by a certain degrees. Then one more is voltage across the coil. This is VR. This voltage across the coil is VR plus VL. Sum of these two phases, VR plus VL. So this is the voltage across the coil. So V coil is equal to square root of V small r square plus VL square. So that you will get V small r is 20, VL is 71.41. So V coil we can calculate as 1 ampere into, for this voltage, if you are taking voltage, then it is 74.15 volts. Next, RC series circuit. So this is an external resistor. This is a capacitor which has got dielectric losses, imperfect capacitor. If it is a perfect capacitor, there will be no resistance component marked in series with it. So this is an imperfect capacitor which has got dielectric loss. To represent that, we are using a small resistance here. So an imperfect capacitor is represented as a small resistance in series with a capacitor. So in this circuit, how to draw the phasor diagram? So it's a series circuit. Let's take current as the reference. The same values are given here also as in the previous case. So this is 50 ohm, this is 20 ohm. This is not XL, this is XC. XC is 71.41. So same voltage, this is 50 volt, 20 volt. Across the capacitor, it is 71.41 volts. Or VR is equal to 50, V small r is equal to 20, Vc is equal to 71.41 across the capacitor. Now what is the relation? This is OA. OA is equal to VR. Then AB is equal to V small r. So both are resistive drops. It will be in phase with the current. This is Vc, voltage across the capacitor. In capacitor, current leads the voltage by 90 degrees. So Vc, if I can mark here, this is Vc, not length is not proper. Can mark here also, this is Vc. So this is lagging behind the current by an angle of 90 degrees. So current is leading the voltage across the capacitor by an angle of 90 degrees. So the same phasor I have brought it here just for adding. So again, the same relationship VR plus VR the whole square plus VC square is V square. So magnitude you will get the same. This is VR plus VR, 50 plus 20, 70 square plus VC is 71.41. 71.41 square root of that, that's equal to 100 volts, which is the applied voltage or total voltage. So this phasor diagram, voltage across the capacitor alone means you have to draw a line like this. This is the voltage across the capacitor, means across this combination. As in the previous case, you can calculate. And the magnitude of this voltage is, say, V CAPL, right? V CAP is equal to square root of VR square plus VC square. Next, RLC series circuit. So here there are three elements: one resistor, one inductor, one capacitor. R is given 30 ohm. Inductive reactance is given. Inductance value is not given. We don't need it. This is 60 ohm. Capacitive reactance 20 ohm. Let I be the current through it. Some values I have taken. That is V is equal to 100 volts. So the impedance of the circuit, Z is equal to square root of R square plus XL minus XC the whole square. Z is equal to square root of R square plus XL minus XC the whole square. XL is 60, XC is 20, so I'll get 50 ohm. So current 100 volt by 50 ohm is equal to 2 ampere. Okay, right. Now let's take a series circuit only. I'll take current as the reference I. First is VR. VR is the voltage across the resistance. That is, its magnitude is 30 ohm into 2 ampere, 60 volts. This is 60 volt. across, this is VL, 60 into 2, 120 volt. This is VC. Let's take it as VC is 20 into 2, 40 volts. Now we can mark. Now voltage across the resistor, we can mark in the same phase of I. This is I. In the same direction, we can mark VR. VR is equal to 60 volts. Then VL. VL is the voltage across the inductor. Inductor current lags the voltage by 90 degree, or voltage leads the current by 90 degrees. So voltage across the inductor should lead current. So this is VL. VL should be leading the current by an angle of 90 degree, because in an inductor, voltage across the inductor and current through the inductor. Current lags the voltage by 90 degrees. So VL I'll mark it in. This is the phasor VL. Then VC. VC is the voltage across the capacitor. In a capacitor, current through the capacitor and voltage across the capacitor. So current through the capacitor, we have here voltage across the capacitor, VC is 40 volts. This voltage will be lagging the current by an angle, because because capacitor current leads the voltage, or voltage should lag the current. So VC I have to mark it here, because it is lagging the current by an angle of 90 degrees. So to add that, I'll take VC here. This is VC. So VR plus VL minus VC. So we get this is the resultant, 0 to for O to this point, and mark the points A, B, C. So OA is equal to VR, then AC is equal to VL, and CB is equal to VC. OA plus AC, and CB is in the opposite direction. So this is the resultant. From O to this point, that is the resultant phasor, that is V. So V is equal to, we can write it as VR plus J VL minus J VC. So this is, or you can find V is equal to square root of VR square plus VL minus VC the whole square. VL minus VC is this length AB. So again, from this right angle triangle, V is equal to OB. OB is equal to square root of OA. OA square plus AB square. So AB is equal to AC minus CB. AC is VL, CB is VC. So if XL is more than XC, this will be the phasor tag. So next case is XC is more. C is more, what happens? This is the reference current I. This is VR in the same phase of I. This is VL. This is VC. In this case, VL has got less magnitude, because XC is more than XL. VC has got more magnitude. So it is VR plus JVL minus JVC. This is the resultant V. So here in this case, the net voltage, the current is lagging behind the applied voltage, because net effect is circuit is inductive. Because XL is more than XC. So net effect is that the circuit is more inductive. But here capacitive reactance is more, the circuit is net effect is the circuit is capacitive. So the net current will be leading the voltage. So here voltage is lagging the current or current is leading the voltage. But in this case current is lagging the voltage. An RL parallel circuit, one resistor, one inductor are connected in parallel. Now this voltage V is common for both these elements. So I'll take that as a reference, P reference. There are two currents. One is the current through the resistor, one is the current through the inductor. Current through the resistor marked as IR, current through the inductor IL. So we know that in a resistor, current and voltage are both are in phase. Here, voltage across the resistor is nothing but V. Current through the resistance IR. So IR and V both are in phase. So this is IR. IR should be in phase with the V. The next current is current through the inductor. So inductor, what is the relationship? Current is lagging behind the voltage. So current should be here. IL should lag behind the voltage by 90 degree. To find the total current, I am putting it here. This is IL. So the total current is I. So this is the total current. This is the applied voltage. So this is total current I. I is lagging behind the voltage by a certain degree. That depends on the magnitude of R and L. So here total current is, so here also some values are given. R is 50 ohm, XL 50 ohm. So 100 volt, 100 by 50, 2 ampere, IX also 2, both are 2 ampere each, 2 ampere, 2 ampere. The total current is, this is square root of 2 square plus 2, this is 2, this is 2, this is square root of 2 square plus 2 square, so square root of 8, that is 2.83 ampere. So the total current supplied is 2.83 ampere. It is lagging behind the voltage. Here this angle is 45 degrees because this is 2, this is 2. So this angle is 45 degrees. Next, RC parallel circuit, same as the previous case. Voltage I am taking it as a reference. This is the current taken by the resistor that is in phase with V. Then one more current is there, current taken by the capacitor. Capacitor current leads the voltage by an angle of 90 degrees. So it should be, this is IC, this is leading the voltage. So this is 90 degree leading. Same phasor I am marking it here. So in this case also same reactance values are given, taken. So this is 2 ampere, 2 ampere, this is 2.83 ampere, root 8, this is 45 degrees. So IC in this case, the current through the capacitor leading. So the net current will come here. So I leads the voltage by an angle of 45 degrees. Then an RLC parallel circuit. So voltage, let's take it as the reference. There are three current taken by the resistor IR, current taken by the inductor, here it is marked as IX, and current taken by the capacitor IC. So voltage is common for all the three elements. All these three elements are connected in parallel. Voltage is common for these three elements. So in a resistor, current and voltage are in phase. So IR we can mark in phase with V. So V is already taken. This is the reference. So this current is IR in the same direction of the V. Then next let's mark IC. IC is leading the voltage by an angle of 90 degree. So IC is, I'll mark O, A, B. IC is AB. AB is leading the voltage by an angle of 90 degrees. Then current through the inductor, which is marked here as IX. So inductor current lags the voltage by 90 degrees. So this is the direction of IX. Same thing I'll put it here. This is B, A, B, C. This is BC is equal to IX. Here OA is equal to IR. AB is equal to IC. Then BC is equal to IX. So current through the resistor in phase with the voltage. Current through the capacitor leading the voltage by 90 degree. Current through the inductor lagging the voltage by 90 degree. Add all the three elements OA plus AB plus BC. This is the net current I. Net current I. So here net current is leading because here the current through the capacitor is more 4 ampere. Capacitive reactance is less in this case. So current through the capacitor is more. So IC is more. So net current will be leading the voltage. So here capacitive reactance is less in this case. So current through the capacitor is more. If it is in the other way, that is, if capacitive current is less, then the phasor diagram will be like this. This is IR. O A is equal to IR. AB is IC. B C is IX. IX is current through the inductor. So current through the resistor in phase with the voltage. Current through the capacitor leading the voltage. Voltage V is the reference. And current through the inductor lagging the voltage by 90 degree. Depending on the magnitude. Here IC has got less magnitude. Because capacitive reactance is more in this case. So OA is IR, that is current through resistor. AB current through the capacitor. BC current through the inductor. This is the net current I. Net current I in this case is lagging the voltage because the effect of inductance is more. Then RLC parallel circuit. So here the only difference is that it's a pure capacitor, it's a resistor. This is a coil. Coil has got the resistance as well as capacitance. Now let's take V as reference. This is IR, current through the resistor. Then IC, current through the capacitor, marked here. Then current through the coil. Coil, current will be lagging, not by 90 degree. Because there is a resistance here. So current will lag. IX, the current through the inductor is taken as IX here. IX will be lagging behind the voltage by an angle which is less than 90 degree because of the presence of this resistor. So that current, this is IX, this is IC. IR, IX is lagging behind the voltage by a certain angle, not 90 degree, because there is a resistor here. If it is a pure inductor, then only it will lag by 90 degree. In this case, it will not lag by 90 degree. So they lag by an angle which is less than 90 degree. Then IC, current over the capacitor, it's leading by 90 degree. IR plus IX plus IC. This is the net current I. So IC, we can mark it here also. I have brought it here. Add it. Current through IX can be marked here also. This phasor should be equal, and I'm drawing it here. The magnitude should be equal and it should be parallel. These two lines should be parallel and the magnitude should be equal. So IR plus IX plus IC is equal to total current I. So I think that's all for today's session. Thank you very much for watching. If you like the video, please share it among your friends and also press the bell icon for notifications.